And 1, 2, 3. I guess I should be live right now. Hello and welcome everyone who has enough time to check this video. That's the fourth video in a series where I discuss how I approach making simple programs inspired by a game that I checked in the beginning. I checked interesting 3D game where I said that a really important concept that is used technically in many games is when some technical solution, like piece of code, allows me to check if two figures collide in any meaningful way. You can describe it as something trying to run in a wall and stopping right there, or trying to think if some sword is actually hitting some enemy, or how big huge enemy can hit you back when he's just running around you, and what your actual game avatar is inside this game world. It's actually a bunch of like figures, shapes and stuff. And I said that I want to explain myself and for myself how all this should work. And that's how I approached it, and it's like fourth video regarding that. Doesn't matter. So what actually matters is, let's just a second. And yes, let's switch to actual programming. So I've made a simple project. Well, simple for those who know how it works, how it's working. If you have no experience with it, it may look really difficult. So it's called hitboxing. It's available on GitHub project. Just a second, who's calling me right now? Hey, nice. Live stuff. Let me turn it off. Yep. So, this is a public website where you can download actual project and open it in your IDE program that allows you to check other people's code and mess with it and run it and so on. This particular project was written in Java, so it would be useful to have IDE called Community Edition IntelliJ IDEA that allows you to open this kind of projects and run it. So let's start first from running. What do we get? Something. Let's wait a bit. Downloading, starting, running, compiling. Yep. So every time it starts, it always starts on second screen. Just a second. And that's it. You can see two squares. One of them can move. The green one with this yellow rectangle. And we finished on the part where when they collide, I can highlight the second one. Like this. So the part that is missing currently is that I want to move in, I would say, two directions simultaneously, but I would say currently I showed you like fourth direction, like 1, 2, 3, 4, and there is also this one, this one, this one, and this one. Yep, so it should be 8 directions. But I actually haven't made a piece of code that would allow me to check shape that is actually rotated by 45 degrees. So it can visually look like they should not sort of intersect but technically, well, you can see it's a bug. We just call it a bug and that's it. They should be active. The square, the smaller one, should be highlighted as activated, and we should understand that they actually like have an overlap. So before I can do this, so there is as with creative writing, there is always this cycle, I would call it. So first you have an idea, then you get some sort of basic description of a thing that you want. So for example, here I got this readme file, and I can say that I want to move my rectangle with arrow keys and try to collide with other rectangles, right? So I used existing project, I hacked a bit, moved stuff from here to there, added some image. I have this particular file called hitboxing that contains most of the useful code. It's about 300 lines, but it would require some time to think it through. But believe me, at least a bit, it's not that difficult. When you get the idea what is happening, there is this create method that is called at the beginning, and we can set up some image loading. We can set up stuff like trapeziums. It's like the debris from previous project that used actual trapeziums for drawing, and now we use rectangles. Also, we set up special handling for input because it's an interactive program, so we have to handle input and some other stuff. The coolest stuff actually happens in render method. Yep, in this one. We check if we should exit, we check again additional keyboard input. We do some stuff with time to make our animation smooth. We check for calculated player collisions. If we have reached the limits of our screen, we check collisions with rectangles. And then we draw the stuff according to our calculations. So we draw rectangles if they should be activated or not, and then we, on top of everything, we draw our avatar, our player. That is not actually a circle entity right now. So that's what we got. I really dislike when I have some piece of logic that works, for example, with rectangles, but it's named trapeziums. Well, why? If it contains stuff about rectangles, it should be named rectangles. So why not start with this? Trapeziums. Set up trapeziums. Okay, set up rectangles. Right? It should be easy enough. So let's try with op. You already can see this red circle. It says one error. And you guess why? Because it's a method. It was already used in other piece of code. And this piece of code now can't be resolved to a proper method because I simply renamed it, but I renamed it only in one place while I should have renamed it in two places. So let's do it like this. Yep. So there was a substitution, an option that IDE provided me so that I wouldn't type it and mistype it, for example. Oh, we also can see some unused import statement. Nice. We don't need those. We don't need line. Fair enough. What again? Okay. We're using redundant array creation for calling varargs method. So you wanna say I could just add... no, I will pass that. I think it's fair enough. So give me some time for my sip of water. I hope. No. Like, this rain shouldn't be too loud, right? So, when I'm working with some stuff, I really want, when I'm speaking about rectangle, and I have some entity inside my code with coordinates, shapes, and whatever that is related to rectangle, to have this rectangle thing in its name. And when it's called trapeziums, it actually started to bother me. Trapezium vertices. Okay, vertices. Do I care about super funny names? Or should I say trapezium points? Or dots? Chords? Okay, so this time I wouldn't rename it simply by changing in one place. I would do a right click. I will find this section called refactor, and I would say rename. as you can see to the right, Shift F6. F6 should be enough for calling this functionality. You can see this rectangle again. Let's call it rectangle points. Let's call them point lists. Okay, so now, as you can see, I changed something and there is no red circle about it, because it was used in multiple places and it was changed in all of those places at once. It can be done by multiple, I would say, solutions, either by changes in, like, trying to go through whole file and changing this particular name. But if you try to change something like I here, it can be difficult because I is also here and here and here, and using refactor in your IDE can be the easiest way to do this. But always be sure what's done, so that you wouldn't mess up something in your code because some fancy program decided for you what you should be doing. Because it can suggest to you, oh, you want to do this, and you click yes, of course, and then you got some stuff that is not working or not compiling, because human perception and software perception are not the same. So sometimes it can fail. Be aware of that. It's okay. I renamed rectangle point lists. Nice. Inactive and active trapeziums. No. Let's call them something like Shift F6. Nope. Why not? Because I should call it like this. No? Still not. Okay, so let's do it the old way. I would say this should be active rectangles. And this one. Interesting. Why it's D? Okay. Okay. It's kind of interesting, but not. Oh, so it actually tried it. No. Doesn't matter. Let's do it like this visually. So, inactive rectangles. Nice. Rectangles. Yes, when you're changing some naming in your code, it may look like stupid, like why would you do this? Because it doesn't change anything. And that's actually the point. When you change naming, the thing that you want to preserve is actually that your program is running. Let's check it again. Yep, still the same stuff. Nice. Escape button, right. So trapezium count. Okay, why it's like this? Shouldn't be like this. Yep, refactor, rename. It should be rectangle count. You can give meaningful names to variables that you use inside your code, and this would actually help you with understanding later, because you may have multiple projects, and when you document the meaning of a variable by giving a proper name, you help yourself not right now, but in the future, if you decide to revisit this piece of code. So this is a maximum number of rectangles that I'm using for drawing in my program. That's it. I call it count, and I use it later in this for loop. Each time, these are like default coordinates. Left top angle. How would I call it? Like left top, right, right. No, it's like left bottom, left top, and right bottom, right, 400. No, it doesn't look like that. 400, yes, it's like left. Oh, so it's like in a weird direction. Why did I decide it like this? Because I thought it should be something like clockwise. Yes, then I do this. I can give a better naming for this, like, it's okay, so left bottom, left top, right bottom, yes, that's it, good enough. These textures do not disposed, heck. Okay, should I care? As I said, I use a special trick to draw active and inactive rectangles. I use it by creating two versions of each rectangle. One with color, like default color, and one with active color. Yes, I create sprites and add them to special lists, inactive and active rectangles. Trapezium activity. No, not trapezium. Let's call it rectangle activity. Rectangle activity. So each time I add vertices. I don't want. This sounds difficult. It shouldn't sound difficult. It should be point list. Really? Active sprite? Is it a list? No, it's an array. Point arrays. Okay. And it should be point arrays. It's not a point, I know it's a float array, but I understand that each pair of floats represent a point. It's just easier for me and for arithmetics in this particular program to use simple float array. It's just bunch, like a fixed length list of float numbers, or numbers with floating point like precision. So this one I want to call it point array. Good enough. So now it makes more sense. We have a state for our program. It has these rectangle point arrays where we add each created point array, right? Then we have this special, I guess, list again. Yes, that contains like current status, if this rectangle was activated or not. If it wasn't activated, then this polygon sprite added to this thing, will be used, and if activity will be true, then this active sprite should be used from this list. It's list, right? It's rather weird approach, I would say. Okay, I know why. We can discuss it later when we get to the point where we can think about sort of a structure for whole program, because now we're thinking about only the things that help us. Like we want to think about rectangles, right? And we do only stuff that is related to rectangles. But if you want to play with some stuff beside rectangles, we would need to understand it too. And after some hours and days, when we forget some details, we need a way to recall, to remember the structure of how we arranged our computations, our code, our logic. And that's the moment where you think about like design of your program or architecture. You can call it like you want. Yes, it's not an issue right now. So let's just... What is this? Should I use it? Get polysprite. Super interesting. Ear clipping triangulator. Well, okay. decent, I guess. So I have active polytexture regions, and only one of them is created at the beginning. Like, why? Get texture, dispose. It doesn't make any sense. That's all I can say to you right now. So I have this variable, right? It's texture region, inactive polytexture region. Like a great naming, sir. And where I actually assign it anything? Polytexture region. It's empty. Oh yeah, moving not in a place. So okay, find usages. Show me the usages. Inactive value, right. Okay, that's the place. So for some reason I missed this part. Texture region, solid color texture. It's part of creation, and that's the place where I set inactive, so default color is created here. You can see it's shade of gray, and we can always change it if you want to add some green, I guess. You can say something like 7 here. Nah, why not? Why should we? Like, let's add something blue here. If I'm correct, then yep, you can see that this rectangle turned a bit bluer now. Bluer, more blue, meh. Okay, nice. So let's make it gray again. Let's make a square gray again. So the stuff is the same. Badge, yep. Okay, active trapeziums and inactive trapeziums. Why we still call them like this? Because these are some variables, I guess. Yes, these are here. Let's change it here. We want to call them by another name. Inactive rectangles. Rectangles. Enter. Nice. And we want to call them active rectangles. Okay, nice. So let's make a quick search. Do we still have something with trapeziums? Oh, nice. We have these and these. Oh, I guess it's the last one. Calculate. Collisions. Player. Collisions with rectangles. That's it. So do we have anything else for trapeziums? No, go away. Right. So the last check. Can we run it? Yep. Pretty much. Same stuff. Great. So that was the main part that I wanted to show you, that there is an easy way how we can approach cleaning up our code just to make it just to try to make it to make a little more sense for us. So every time you see some piece of code and you're not sure does it make anything useful, you can always try and, for example, comment it out. You add 2 slashes at the beginning like this, or use Ctrl/ like this. And when, as you can see, I commented it out and nothing changed. So let's try and do something with this. The beauty of programming is that you can iterate and play around with your code. Well, Doesn't look that bad, right? Let's try moving. This looks a bit weird. So you may think like, well, why this is happening? So as I said earlier, every time you decide to move something, you get a new position for your player, right? And if you want to draw it, then the easiest way is to actually clear everything out and start from scratch. First you draw the active and inactive rectangles, and then you draw a player. So the thing that I actually commented out was the cleaning phase. So now you are drawing active, inactive rectangles and player on top of the stuff that happened earlier. And that's how you see this weird looking drawing program. Doesn't look that bad, and you actually can play with this just by commenting out some pieces of code and trying to understand what the heck is going on. It's okay. Let's remove these comments. Nice. There are moments, I guess, that when you can try to understand, like, why I'm not getting, why I'm not moving to the right as I want it, right? For example, you have an issue here, and you're not sure what should be done here, and you want to just check something that, okay, if A is pressed, okay, not A, if for example left or right is pressed, can I do something like, can I do something useful with this? No, really? I'm pretty sure that I should be able to do this. Yep, GDX app. So, okay, Ctrl Z, app. If I want to log something, okay, we can use login simply with system out print line, but I guess this would be more useful if you would try to use, for example, Android as a platform where you run your application. So let's use this tag like hi, and like what do we plan to show here? Maybe input state, because why not? And we want to this keyboard state and then toString to actually, now I can toString. Nice. Let's try. So every time I hit right and it's detected, I want to see a log not as in tree, as log as in login with 2 G's, information about what is happening inside my program. You can say, yo, you can use debugging for this. Well, sometimes it's really difficult to use debugging, and login information can be easily shared if you, for example, know that on your machine everything is working as expected, but on your friend's machine something is shaky. You can try to add this login information and ask a friend to save those logs so that you can check them on your own, for example. So let's try again running our application. So, okay, we can see I want to move to the top, then to the right. I did it exactly one time, so expect one time there should be this log stuff, or multiple times, I don't know. Let's see it together. Yep. To the left you can see some details of how my program was running. Finished with non-zero exit value. Oh my god, how could this happen? Maybe I just don't care. So what I actually wanted to see, you can click not on this process result, but on this desktop launcher main. And here you can see this tag that I added hi, and you can see a stringified version of my input state. So if you wanted to know what is going on inside some structure, you can actually try to log it and use to stringed version, and there is a chance that you could see what is going on inside it. So in my case, I have a state for buttons that I'm checking, and these are buttons for arrows. No, not for arrows. Yes, down, left, right, and up, and for 4 letters: A, W, S, and D. W, A, S, D, right, for running. So in my program, and if you decide to run it and modify it in your program, you can use both arrows and WASD for moving around. That's it. Let's move it back. I don't need this stuff anymore, but it's still useful to know. Okay, so where we gonna move later? What we have now? We don't have any trapeziums left. I guess we have only rectangles. I wanted to show that why would we spend so much time with this, like prettying up the code. So as I said, you begin from something, for example 2 rectangles, and you want to improve this code, to play a bit, not with commenting out some useful code, but actually with adding stuff that your imagination like whispers you to try out. So as I said, we should try to collide our player not with 1 rectangle, but for example with 2 or with 3. So we should have multiple rectangles configured for our application, right? So sorry, but I need to make a short break. I'll get back in, I guess, 4 minutes. While this, please check. You can check the code that is like the interesting side should be with this array, with this counter, and that's it. Yep. Give me a second. Not a second, give me about 4 minutes and I will get back. See ya. Oh, sorry for bump. So I'm back. The moment where I stopped was regarding when we cleaned up our code. It should be a better place to have our ongoing experiment with how we want to improve it and add upon the basement that we the basis that we laid earlier. So we have drawing, we have moving, we have stuff, but the thing that actually was in previous program that is missing currently is we have this loop for actually creating sprites, for drawing multiple rectangles, but we use exactly one rectangle. And that's kind of boring, right? What we are missing is that we have these like coordinates. So for stuff like this. Well, not exactly. I'm a funny guy. Just a second. There's so many things I have to have. So yeah, more like this, right? So we have this, and we want to have another one, and another one, and another one. What we can do for the beginning is to keep the dimensions, like how wide, how high those rectangles are, the same, but we still need to have, for example, we think about these structures as if they have a starting point, left bottom corner, left bottom corner, where we start our rectangle, and it's different for each and every of these rectangles, but they have the same dimensions. So how would I try to replicate the same situation in my code? I do know that I have a place where if I modify these coordinates, I will technically modify the dimensions for my rectangle, right? But it's not enough. Let's try to improve this. For example, as I said earlier, I want to have fixed width and fixed height. How would I achieve this? I would say final int. Final as mean I'm not planning to change it. Int as an integer. It's not a floating point number, it's integer number. It will be width, for example 100, and it will be height, for example also about 100 pixels. Where would I use it? So here I can see that these first pair should correspond to the left bottom of my rectangle. So I would say this is a starting position and there is no width or height used for it. Okay, so what will be next? I would say that we go to the higher, so we actually add something to a starting position. We add actual height to our position. So we do next. What we do next? We go from the previous point to the right. So we add to the starting X position height. Oh, why height when I should be adding width? And then I'm adding to my height, to my Y position, this height. And then what I'm doing, I'm moving to the bottom, like lower. So I keep the same width. So it should be 400. I would say it should be like this for readability. Yep, and this should be 400 plus width. And we have starting point. So now I hope that you know the Cartesian coordinate system, where it says that we have this when we want to play around with geometry, with 2D stuff, it's called 2D because we have 2 dimensions, and for actually measuring, for calculating, coordinating them and coordinates, we have this idea in our mind that we have, yes, it's a pencil. So, no, that's a great line. No, that's fine. We call that when we move to the left or to the right, we call it axis, and we gave it a name of X. Not because it's an axis, just because reasons. And then when we move to the top or to the bottom, we call it the axis of the name Y. Again, the question why, I have no answer, really. So when we say, what will be the beginning, this like crossing, like crossroad. Okay, this point where the x-axis crosses the y-axis. Well, each point that we put here, for example, I want this point somehow name it. How would I name it? I name it by using two numbers. One of them will be x0 and the other one will be y0. In that way, I can say that I give you the coordinates of this particular point, and this point has coordinates x0, y0. If we move to the top, for example, we decide that this will be 1, and this will be also 1. Then this point here will have x of 1 and y of 1. If we decide to move, for example, oops, that's fine, I guess. And here you can see -1. Then this point will have x of -1 and y of -1. That's the way how we can pinpoint the specific point on a screen and be sure that when we say 0, 0 and we start drawing from 0, 0, it will be the left bottom, right? That's the value of all this. And when I say I have a rectangle, it should have 4 points, and each of those points should have coordinates, right? Described as x and y. That's why it's a pair, because if we use only one number, it will make sense only if we are using single axis, and we can't draw a 2D, two-dimensional stuff using only one axis. We need at least two. The same applies for 3D. If you want to play around with 3D, then you would need not 2 numbers, but you would need 3 numbers, because technically you would have another axis that would go like this and will have name of Z. X, Y, Z, right? But it's beyond our discussion right now, because 2D stuff is easier to understand and play around and start with, and if you really want to dig deeper with 3D stuff, you can find plenty of resources how to break your head with it. So, the thing that I have right now, does it work at all? Let's try it. So, to me, it looks like it's the same rectangle. If I'm correct, then I can change height to something like 150, and I expect that when it will be drawn, it should look a bit taller, right? Makes sense. I hope. So, back. I still want squares. Just a sip of water. So, what do we have now? As I said, now we use width and height that I described earlier for setting the points that will be the description of our rectangles. Or one rectangle in this at this time. But I still don't like that I always copy paste this 400, 400, 400. Are they pointing to the same value? Why 400? What if I decide to change it? What if I want to move this rectangle somehow? How would I do this? Currently you have to modify whole numbers and be aware which of them is x and which of them is y. Which is kind of, well, it's easier to mess up. I want to say that I have integer number of start x, which is 400, and I want to have start y, which is also 400. And now I can actually copy paste it like this, this, and this. And I can say that this one, this one, this one, and this one are about Y. Why would I do this? So let's try move this thing a bit to the right. How would it look now? As you can see, it's moved to the right. And if I decide to move it a bit to the bottom, yes, it's moving. And also, when we move our player, yep, everything working as expected. So, the most interesting part, can we do something with this code so that we can maybe add additional rectangle without breaking everything that we got done before? And I have a suggestion for you. So currently we have this loop that goes from 0 to 1. Let's move it to 3, for example. I know that width is about 100 pixels, so I would say, so if I run it now, I would have 3 rectangles which are drawn one on top of the other, which kind of boring. Well, let's give it a try. Will there be any failure or something? No? It has like a bit nicer color because three rendered colors give you like a deeper shade of gray, but it's still not that interesting. So for example, I decide I want a row of these rectangles. How would I achieve it? I understand that in my case they should have same dimensions, like dimensions as width and height, but they should have different starting coordinates. So if I want a row, not a column, then I would change X part. If I just change it once, then again I would have 3 rectangles with the same starting position. So somehow I should make it possible for multiple rectangles to have different starting position. And that's the point where I'm using this weirdly named thing called I as counter identifier. I'm not sure, because it's just from math that we decided that when we have a loop, number of iterations of the same code, we want to have the number for current iteration. So maybe it's iteration, but you like it's a counter for iterations. It's not iteration itself. So that's the starting position for our value. That's the condition where we stop, and that's the way we change it. We can add +2. We can like remove this stuff, and it would work like infinitely by just burning our computer and drawing nothing interesting for us. But what we're gonna do, we already changed this value from 1 to 3. So it will go from 0, then we'll finish it, increment it once, there will be 1, 1 still less than 3, then increment again, it will be 2, 2 still less than 3, then increment again, 3 is less than 3, no, they're equal. So this condition will not be met, and that's the end of this loop. So now we have this I number that will be once 0, then it will be 1, then it will be 2. How can we use it? The simplest way that I can imagine is doing something like this. It's not the best one, but it should work, I expect. Let's check it out. So like it's working not because I have some super tricky program behind me, that behind my back, that is adding something, but because code is simple and you can try to imagine it in your head before you trying to actually write it, because it's the way that you predict what machine would do, and if your prediction works, then it's nice. You still understand and you sort of control what is happening. And if you add something and it's failing, then maybe you're moving too fast, or maybe you missed something simple and you should Ctrl Z to move back to some stable state for this. So are they working? If I move here, yes, it's green. And this one. And this one. Yep. So I would say let's move it a bit. I don't want it to be like that, actually. I wanted something smarter. I want it to be dependent on this I value. I want this I value to be multiplied by width, and if I make it only one width, then there will be like I would say smashed together, and that's not what I want. I want to have some distance between them, so I would multiply again, but like this. Would it make sense? I guess yes, it should make some sense. So let's run it. Yep. So now I have 3 rectangles, and they are not starting from the 0, and they still have some distance between them. As you can see, yeah, there is collision for 2 of them at once. I would say that's sort of a success for this small program. I still need to make a proper collision detection for rotated version, but I will keep it for my next stream when I would want to make changes in another class that I use here. It's called currently circle player or something like this. Let me check it. So I have a piece of code that says something like calculate player collisions with rectangles. Yes, and where I use this circle entity player, right? And it's not a circle. It's definitely a rectangle, and I should rename stuff and get away from this radius. But it would require usage of I would say data structure that I used here, a class in terms of Java, and it wouldn't be really easy and fast to describe it in simple words. So I would leave it for next discussion, and for now I would just say that anytime I have some stable version of my code, I prefer to save it. And you can say, sure, you would save it because you don't want to open next time and write it again. No. I mean saving my project in a more... I can share like... I'm not sure that you can relate to this easily, but imagine that you're making a photo of yourself each day. And you're doing it not using a simple photo camera, but some magical photo camera that checks everything inside and outside of you. So next time when you decided, oh, at that moment in time I went wrong, I want to get back to my state when I was at this particular day, and you say something like revert to this state, and you voila, and you just there. So imagine the same thing, but not for yourself, but for your whole code structure, for all the files and classes that you created. At some point in time, it's working, right? And you make sort of a snapshot, sort of this magical operation that saves everything at once and gives it a special name. When you save whole state of your programming project, whole state, and give it a name, and next time you, for example, decide to play with something and you break something and you don't know what to do, instead of thinking about how would I revert to back, you already have this special mechanism that allows you to forget all the latest changes in multiple files and get you back to a specific state when your program was working. So in terms of programming, it's called control version. So here it should be something like, yes, version control system. So it's like saying that each saved state of your program is saved version. It's like versioning, as saying that you have program of version 1, then you have program of version 2, and so on. So these particular saved states are called versions, and the system that allows you to control them is a version control system. I'm not sure that it makes enough sense, but the cool side of it is that when I decide that I want to save this stuff and I want to share it with other people, they don't need to access my particular computer, because I can share it using this control version system that is used on this service called GitHub. And if you check this part with 3 commits, each commit is a version. And you can see that there was initial commit, initial version, and you can check what were the states of different files and what was there. You can check what was changed in next version. You're not looking at everything at once. You're looking only at changes. And you know what? I just added one file called square svg. Another one was square png. It's about binary file not shown. It's like an image. And the third version, yes, it was about my changes that I did on previous stream, that I changed from player to square png. So I added fault arrays. In that way, you're not only saving a particular version, but you can also check what was changed, what have you tried, what have you done, and what pieces of code were removed, and which pieces of code were added. So the green stuff was added, and the red stuff was removed, because I didn't need it anymore. Repeat sims. So the same way, if you give me some time, I just don't want to bother you with the description of how to use UI for this particular program. So just try to, how I would call it, just believe me that you can do it. You can check different ways how to approach this particular task of creating a new version of your code, and how you can upload this version to site called GitHub or any other that is useful for your project. So you saw that I did multiple changes in my code and it's working, right? So now what I'm doing, I'm saying this, okay, please program, tell me which files I have changed. And it says, oh, you have modified hitboxing.java. I said, nice. Can you sort of keep it in your like internal program structure for a moment? And it says, yes, okay, I can. And I say, okay, I want to create new version for these changes. I want to call it cleanup went well. It's like a short description of what have you done for this particular version to be interesting for you. And then I want to say that, okay, I have my local version for this, but in case my computer dies and this whole building is burned down, I still want some other people to continue to work with it, because why not? Maybe they would find it interesting even after I stopped working with it. And they still want to have full picture of what was done and what was changed. And I say, okay, take my changes, please, for this particular project. And as everything is set up for me to send it on my account on GitHub, I want to move these changes on GitHub. And I say, push them. I check, I see everything was pushed. So if I have done everything properly, you can check it with me now. Yep. So that's still browser with versions. That's still the project. But wait a second. You can see the changes were added 1 minute ago. And there is now not 4 commits, not 3 commits, but 4 commits, right? Cleanup went well. Nice. So what was changed? And you can see 2 unused imports removed. Active trapeziums, inactive trapeziums renamed. It says that they were removed, but it doesn't matter. So there was some renaming. There was a method called setup trapeziums, and now it's setup rectangles, right? No trapeziums. So we have trapezium count of 1, and now we have rectangle count of 3. We have renaming again, right? There was this particular structure of approaching fixed creation of one number of points, and now we have our logic that actually depends on number of iteration that changes the coordinates for our rectangles and adds them to specific lists. What else do we got here? Some boring renaming. Yep, that's about it. And now you, when you try to actually download this project, if you really want it, using this code, this like link, and adding it to your IDE, you would get the latest version from this particular site. If I would keep like mirroring my local version with this GitHub version, then you would always stay up to date. And if you decide to use GitHub, then you wouldn't be able to push your changes in my particular project. The thing you would need to do, for example, let's check any other pull requests, marketplace. No, I want something with game, right? Okay, so for example, we can see this project of Delafort game something. What is this? Something with JavaScript? Ooh, a game. So for example, you want to work with this particular project and you want to share your changes with this person. You can do it just by pushing your changes here because you're not an owner of this particular project, right? So how would you approach this? There is a logic called forking. It would create a complete copy of this particular project, but it will be tied not to this person account, Delafort, but it will be tied to your personal account. So if I would try to do this right now, I would move it and create the same game, but for Smash That Code account, and I can work with it, make changes, and if later I would decide that I want to share my changes with the author of original project, then I can make a request if they want to get them, if they maybe want to give some feedback. That's the way modern development is done, in a like asynchronous distributed manner, when people from multiple places can help you with some project, or maybe share their ideas, or maybe just try to play with your code. Should they pay to you anything? Well, not necessary. In my particular case, I can't see any way why they would need to pay me this stuff, because I decided that these kinds of projects should have a special way of saying, like, hey, it's free. It's free as in free beer, and you can do anything you want with this. It's called licensing, and I have this particular license called MIT. It says that you can use whatever you want with this. No one can say to you, like, oh, you took this from internet, then it should be piracy. No, it's not piracy. It's 100% legal in every country. Well, except countries where you are not allowed to visit internet and so on. And that's it. That's all I wanted to say regarding the project. Maybe 2 more minutes regarding what will be our next steps. So, already we got some stuff with hitboxes. Everything looks pretty much okay, except we have this ability for our player to move in diagonal ways, but we don't have this collision detection that would allow to check if player is in diagonal manner or not. So for this, we would need to modify structure that is keeping data about our player, and it's currently doesn't suit our logic at all. No radius, x, y, like y, and there is no simple way to understand if it's like rotated or not, if it's rotated by 90 degree or 45 degree. That's kind of lame. Yes, we have this still based on radius, and this should be fixed. It's not okay. This reminds me, like, how stupid should I be? If I have this boolean value and I here set true or false while this is true already. That's another way how you can simplify your code. That's kind of sad. So let's check it again. Is it working? Yep, it's working as expected. So again, intro, I do the boring stuff. How would I call this version of mine? I would call it git add, git commit. I would call it make write simpler code. Wrote. Make it simple. Okay, and then I push my changes. And if I've done everything properly, then I should be able to show it to you, right? 5 commits. And the last one, make it simple, is related only to this. Because maybe I tried to make something smart there, but no, it doesn't look smart. That's it. So, yes, we still have some changes that we need to do this to make our code readable, sort of easy to understand, and sort of like usable if you decide to play around with it. I guess there are still some hidden stuff about input geometry and other. I'm not sure that I really want to play with it. Sounds super boring. Input state. Meh. I guess it would require creation of additional super dumb project that has no movement at all. Why would I need something like this? I want to start with something that's already working. Yep. So no more wasting time here. I wish you all the best. I hope you would have a great time writing your programs, prototyping, being inspired by stuff, and trying your best to learn it, and not by watching someone else, but actually writing this stuff in your own IDE on your own computer and getting your own experiences if actually you find something of this interesting. Because like as a hobby, it can be super rewarding, but at the same time, the main idea of these streams is that sometimes simple things actually require a great amount of time and I would say mental effort to finish them up. And like sometimes doing simple stuff, like making things easier for yourself tomorrow or after a week, these small changes in your way you approach writing small programs can be really useful for you and for the joy of learning something new in programming. That's about it. Wish you all the best and see ya.